This is Unit 4, Lesson 4 on adding and subtracting rational expressions. Here's a rule, one denominator to rule them all. That's right, we have to have the same denominators. So let's check this out. Our objective, by the end of class, I can add or subtract rational expressions with unlike denominators by factoring, finding the least common denominator, rewriting, and simplifying. So, what do you remember about how you add fractions? When you add fractions, you have to have a common denominator. So, this example here, I have 1/8 plus 1/12. A lot of times, people choose to multiply the denominators. So that would be 8 times 12, which is 96, and use 96 as the common denominator. What did I multiply 8 by to get 96? Well, I did 12 times 8, so I have to do the same to the numerator. So I would bring the numerator down to 12. How did I turn 12 into 96? Well, I multiplied that by 8, so I have to multiply the numerator by 8 as well. So now you can simplify by just adding straight across, because everything is over 96. You have a common denominator. 12 plus 8 is 20. Then we would want to simplify down further. How does that break down? 20 divided by 96. Oh, let's see. I know that's 10 if I divide it by 2. And 48. That still can go down more. 5 over 24. That would be my final simplified fraction. Now, that was multiplying the denominators to get a common denominator. Others choose to find the least common multiple or least common denominator of 8 and 12. If you list out what the multiples of 8 are, you have 8, 16, 24, 32, let's just go up to 40. And then if you list out the multiples of 12, you have 12, 24, 36, 48. I'll stop there. Do you see a multiple that they have in common? If you said 24, that is correct. So that is the least common multiple of 8 and 24. So if I'm going to turn the denominator into 24 here, what do I multiply 8 by to get 24? So 1 over 8 has got, I'm going to turn it into 24, so I multiplied that by 3. So I need to do the same to the numerator. 1 times 3 is 3. How do I turn 12 into 24? Well, multiplied it by 2, so 1 times 2 would give me a numerator of 2. And now I can add straight across 3 plus 2 to get 5 over 24. So that is another way that you can add those fractions when they have different denominators. So let's talk about if they have, if two or more rational expressions already have the same denominator, then just like those fractions, you can add their numerators. So if the denominator here on these three terms is x minus 9, then I can put everything over x minus 9 that's in the numerator. So I can carry my 5x over, my plus 7x, and then I have minus 2x in the numerator. So as long as you have a common denominator, you can do the addition and subtraction in the numerator. Okay? So of course they're not going to be that easy every time. Sometimes you have different denominators. Or are they? Remember when we did the the expressions, they look like they are different, but they're actually the equivalent form. X plus 9 times x minus 9 and negative 81 plus x squared. Well, this looks similar if I rearrange x squared to x squared minus 81. That's my difference of squares. That factors down to x plus 9 times x minus 9. So sometimes you have to manipulate the denominator to see that they actually have the same denominators. So now that we have the same denominators, I can put everything that was in the numerator all over my x plus 9 and x minus 9. And then once I've done that, I'd want to add the like terms in the numerator. So I have 18 and 24. That adds up to, well, I'll say 44. No, 42, sorry, 42. And then negative 3x plus 2x, which is be minus 1x. And that's all over my x plus 9 and my x minus 9. And that is fully simplified, and I added the rational expressions. Let's take it to another level. Let's look at when they have like denominators, but we're subtracting. So I have the like denominators, so I'm just going to write x plus 5 and x plus 3 in the denominator. And then in the numerator, I have x squared plus 15x. Now here's the trick here though. I am subtracting this whole numerator here. So I have to distribute that minus sign. So that would be minus 3x plus 35. Okay, that's the difference on this problem. Now combining the like terms, we would get x squared plus 12x plus 35. And that is all over x plus 5 and x plus 3. And I'm going to stop there. Look at it for a minute. Well, what about the numerator? Sometimes those factors divide out. So x squared plus 12x plus 35, can that be simplified? X squared plus 12x can factor down to x plus 7 and x plus 5. Oh, I didn't need that extra x there. There. X plus 7 and x plus 5. And that's all going to be over x plus 5 times x plus 3. What can I factor out? Well, this becomes 1 here, so my final answer would be x plus 7 over x plus 3. And that is fully simplified. So we are going to have to be checking that we fully factored the numerator and the denominator. So our rules here to find the least common denominator. To add the rational expressions, we need one shared denominator. We're going to build the least common denominator by listing every unique factor from both the denominators, using the highest power that appears. This keeps the denominator small, yet complete. The least common denominator is the smallest expression containing all denominator factors. And that a factor is the number or variable that divides exactly into another expression. So to combine and simplify, we want to make sure we're factoring the denominator, break every denominator into prime factors. That's going to reveal all the pieces that we need. Then create the least common denominator, multiply each distinct factor, each single factor using greatest exponents to craft the shared least common denominator. Rewrite the numerators, so multiply the top and the bottom, so each fraction's denominator equals the least common denominator. And then combine by adding or subtracting the numerators, and then cancel out any common factors with the least common denominator. So let's put this to work. We have different denominators. Most pairs of rational expressions will not have a common denominator, as given. In situations where you want to add these, you must determine the least common denominator. So here, this one's just set up with numbers in your denominator. What is the least common denominator that I can find for 12 and 5? And if you want to multiply the two, that's going to give you 60. So let's do that. Put them both over 60. But how did I turn 12 into 60? I multiplied it by 5. So I have to do the same with the numerator. I have to distribute the 5 to everything that was in the numerator, because what I do to one, I have to do to the other. So that leaves me with 15x plus 100, 20 times 5. How did I turn 5 into 60? Well, I multiplied that by 12, so I have to do that to the numerator. So that gives me 48x in the numerator. Now I put all of that over 60. 15x plus 100 plus 48x. And 15 plus 48 is going to give me 63x plus 100 all over 60. And I have finished that problem. If I could find something that would divide 63, 100, and 60 evenly, I could simplify that more. But since 63 is an odd, I don't think I can do that. I can divide it by 3. No, it won't go into all 3 of them the same. 7, nope, not 7 and not 9 either. So this is completely simplified, my final answer. So don't forget, you have to do the numerator and the denominator. You have to change them both. When you are changing the denominator, you have to change the numerator. Let's look at another problem. Now we have algebraic expressions as the denominator. So let's break down these expressions. This one is just x. Let's expand them. This one is 2 x's. And this one is a 2 and an x. So the highest exponent, remember, is the rule. Which one is the highest exponent? This x squared. Good. And then which one is the number they have in common? This one has a 2. So the factors I have are 2x squared. Okay? So I can turn each one of these denominators into 2x squared. So that's what I plan to do. Let's go back and look at that rule, what it said to do and how to do it. Break every denominator into prime factors, and that reveals the pieces that is needed. That was our x, then one had 2 x's, and one had 2 times x. Those are the pieces. Multiply each distinct factor using the greatest exponents to craft the shared. So this is my greatest exponent here, x squared, and this is my number here, Okay, they have a 1 here and a 1 here, so if I multiply those, I get just 2, and that's going to give me the least common denominator. So let's go back to that problem where we left off. So if I want the denominator to be 2x squared on this first term, what do I need to multiply it by to get 2x squared? That needs to be multiplied by 2x on the top and the bottom, right? So I get 2x squared, and then 2x times 3 is 6x. The next one has x squared, but I want it to be 2x, so I can multiply this one by just 2 over 2. So that would be 12 over 2x squared. And minus the 2x, turn it into 2x squared, I need to multiply that by x over x. So I would get 4x squared over 2x squared. All right, so that is how we would do that. Now let's put all of that. Now you could do this a couple ways. I could simplify each individual one first, or I could add them all first. Okay, let's do it that way, because if I simplify them, then I'm kind of back where I started from, aren't I? I would be back to 3x if I took out the 2x that they have in common. That just defeats the purpose. So put it all over 2x squared. 6x plus 12 minus 4x squared. Alrighty. I can factor out a 2 out of everything, and that's going to give me 3x plus 6 minus 2x squared all over x squared. Let's look at that. I'm going to rearrange that. I want to put my x squared first. 2x squared plus 3x, kind of in standard form this way, plus 6 over x squared. Can my numerator factor? I have a trinomial in the numerator. Can my numerator factor? So it cannot factor any further, so that is going to be my final answer. Try another one. So factoring the denominators. So find a common denominator. We sometimes have to factor those denominators. So there's 4 things you can look for. You can look for greatest common factors. You can look for a difference of squares, those identities. You can look for the perfect square trinomial identity. And if it's not factorable, then the denominator is fully broken down. Okay, and that's what we want. We want to try to break it down fully. So remember your trinomials and those patterns of perfect squares. And remember the patterns of the difference of squares. Which is the correct factorization of x squared minus 16? Can you recognize what type of binomial that is? Now, I can test out each of the answers down here to see if I get back to my original problem here. Let's just start on the right here. If I distribute the x to both of these terms, I'd get x squared minus 16x. Does that match x squared minus 16? No. Let's try this one. X minus 4 times x minus 4. Distribute the x. I would get x squared minus 4x. Then distribute the 4. I get minus 4x plus 16. So that becomes x squared minus 8x plus 16. That definitely does not match. Let's try the next one. X minus 8 times x plus 2. X times x is x squared. X times 2 is 2x. Distribute the negative 8. I get negative 8 times x is negative 8x, and negative 8 times 2 is negative 16. Combining the like terms, I get x squared minus 6x minus 16. Well, that doesn't work either. So I guess it's going to be a difference of squares, where my first term's a perfect square, my second term's a perfect square, and subtracting in the middle means it's a difference. And it factors down to x minus 4 times x plus 4. Well, let's go ahead and test this out. X times x is x squared. X times 4 is positive 4x. Negative 4 times x is negative 4x, and negative 4 times 4 is negative 16. Combining like terms, the two middle ones will cancel each other out, leaving me with x squared minus 16. So this is the correct factorization of x squared minus 16. Knowing those differences squares and being able to recognize them is going to be really helpful when you're trying to work these rational expressions. All right. Think, what is the least common denominator? All right, we have z squared minus 6z plus 5 and z minus 5. Look at this and see what one of our tools that we're going to use to find the least common denominator. All right, so I hope you recognize that this trinomial needs to factor to, whoops, give me my pen back. Trinomial needs to factor to two binomials with z. What are the factors of 5 that add up to negative 6? That would be negative 5 times negative 1. Negative 5 times negative 1 is positive 5. Negative 5 minus 1 is negative 6. So you should recognize here that you have z minus 5 on both sides, but what does one side have that the other side doesn't? This side over here does not have a z minus 1. So in order to put it over the same denominator, I have to multiply the numerator by z minus 1. So I'm going to do that. I'm going to multiply everything in the numerator, z, or in this term of the numerator. Z squared times z is z cubed. Z squared times negative 1 is minus z squared. And then I need to distribute the 3. Negative 3 times z is negative 3z. 3 times negative 1 is positive 3. So that's what the numerator of that second term is going to be. So I'm going to now rewrite everything over z minus 5 and z minus 1. Because it's a plus sign, I have 11 minus 2z plus this whole second term that we made, z cubed minus z squared minus 3z plus 3. What do I have to do now is combine the like terms in the numerator. So I'm going to do my largest one first, z cubed, okay, minus squared, and then I have negative 2z and negative 3z, which is negative 5z. I don't like z's, they look like 2's. Maybe I should just put a little crossbar in there, you'll know those are z's. Let's do that. Okay. And then 11 plus 3 is plus 14. All of that is going to be over z minus 5 times z minus 1. Now, if the numerator could be factored by grouping, I would do that, but I can tell that that's not going to factor by grouping. So this is going to be my final answer. My final answer. All right, let's keep going. Let's try some practice here. I want you to pause this and try to add 2 divided by x minus 5 plus 3 over x. So pause it and try this problem. All right, how did you do? So looking at the denominator, one is x minus 5 and one is x. So if I want them over the same denominator, if I multiply the two of them, I want it over, whoops, I need my pen back, x minus 5 times x, and I'm just going to put that x in front, it's okay. So this first one, I'd have to multiply it by x over x, which would give me 2x. And then the second one, I would have to multiply it by x minus 5, which would give me 3x minus 15. So did you get that far? All right, now let's change it to combine like terms, which would give me 5x minus 15 over x times x minus 5. Just to check it, I know I have a GCF on top. Let's take that out. X minus 3. Okay, so nothing's going to cancel out here. I'm going to be just left with 5 times x minus 3 over x times x minus 5. How did you do? Did you do okay? Okay, let's keep going then. All right, so here are 2 problems for you. Answer both of these problems on a piece of paper and see how you do. Take 2 minutes and solve this. Give it a pause and do that. And we'll see our answers on the next slide. All right, let's see our answers here. How did you do? Check your answers. X squared plus 3a minus 6 over a minus 4. That was the first answer. The second one was 60h minus 100 over h plus 4 times h minus 2. How did you do? Let's go over each of them together to make sure you understand. So the number 1 has a common denominator. We already have a common denominator. So all we have to do is the operations that are in the numerator. So a squared plus a minus 6 plus 2a. Combine your like terms to get a squared plus 3a minus 6 all over a minus 4. Check that the numerator does not have any more factors. Are there factors of negative 6 that add up to 3? They are not, so that is your final answer there. Okay. Now the bottom one is a little bit different. So one is x plus 4, one is h minus 2, and one is h squared plus 2h minus 8. So I want to try to factor the 3 term, the trinomial here, see if it factors. H and h are the factors of negative 8 that add up to 2. Positive 4 times negative 2 give you negative 8. Add them together, you get positive 2. So now what do you notice? I've turned the denominator into h plus 4 and h minus 2. That's going to be the common denominator. So how am I going to get the first term to have h minus 2 in it? So I have to multiply the numerator and the denominator here by h minus 2. And on the next one, I have to multiply it by h plus 4 over h plus 4. Okay, I don't like h's either. So 56 times h is 56h. 56 times negative 2 is negative 112. plus 3 times h is 3h, plus 3 times 4 is 12. And then bring down the plus h over the third term, all of that over h plus 4 times h minus 2. All right, so notice how I had to multiply. Just because these two matched, these two, they didn't match. They have one of the factors. They have to have both of the factors to be common. Okay? So let's go ahead and combine our like terms here. 56h plus 3h plus 1h gives me 60h's. Negative 112 plus 12 gives me negative 100. All of that over h plus 4 times h minus 2. Final answer. Okay. Find the least common denominator, rewrite and simplify 5 divided by x squared minus 4 minus 3 times x minus 2. Let's pause this again. How we do. I'm going to always write these again when they're listed like that because I don't like the sidebar. So let's rewrite those. 5 divided by x squared minus 4 minus 3 over x minus 2. What do you recognize here on this first denominator? It's a difference of squares. Good. It's a difference of squares. So that's going to factor down to x plus 2, x minus 2. So now, do they have common denominators? Almost. This one over here has half of it, x minus 2. So I need to multiply it by x plus 2. Okay? When you're multiplying it by x plus 2 over x plus 2, you're really only multiplying it by 1 because it's the same on the top and the same on the bottom. So you're not changing the number. You're just giving it an equivalent form of that number. So that's why it's mathematically correct to be able to do that. So I'm going to bring down my 5. I'm going to do 3 times x is 3x. And I need to subtract that, so that's going to be negative 3x. 3 times 2 is 6, but I need to subtract that, so it's going to be negative 6 over x minus 2 and x plus 2. All right, combine your like terms. You get negative 3x minus 1 over x plus 2 and x minus 2. Your final answer. Are you catching on? Is it coming along? All right, let's try one more problem here. Let's see how we do on this one. And again, I'm going to rewrite this so it doesn't have that slant in there. You see, right away, you're going to be able to factor both of these denominators. This one's going to factor as a perfect square, a difference of squares, so that's x plus 3 and x minus 3. This one's going to factor factors of negative 6 that add up to negative 1 is negative 3 and positive 2. So I have close to the same. I have x minus 3 in both of them. But this one is missing x plus 2, and this one is missing x plus 3. So I need to multiply the numerator by those. So 2 times x plus 2 is 2x plus 4, plus this one's got to multiply by x plus 3, so 4x plus 12 all over x plus 3, x minus 2, and x minus 3, all three of those terms. Let's go ahead and combine our like terms. 2x and 4x is 6x. 4 plus 12 is 16. All over x plus 3, x minus 2, x minus 3. Doesn't matter what order you write those in, as long as they're all there. If you want to take a 3, no, we can't take a 3 out. I can take a 2 out of the numerator. That gives me 3x plus 8. All over the same denominator. So are you able to start recognizing your special cases here and how to factor to get common denominators? All right, that is everything I have for you in Unit 4. If you have any questions, please reach out to us. We're happy to support you. Now you need to go do your IXL practice to work on these problems some more. Have a great day.